Good morning, good afternoon, good evening, friends from around the world. My name is Dr. Murali Tumarukudi. I am the Operations Manager for the Crisis Management Branch based in Geneva. I'm extremely happy to invite you to this webinar towards responsible AI for disaster risk management. This is part of the webinar series ongoing on AI for good this year. So without much ado, I'll start the session by inviting Dr. Bilal Jamoussi to the session. Dr. Bilal is the chief of the study group department at the International Telecommunication Union Standardization Bureau in Geneva. Before he joined the ITU, he used to work with Nortel in Canada for 15 years. And unlike most people in the UN system who are more program managers, Bilal is also a scientist with 22 patents to his credit. Bilal, you have the floor now.
Thank you very much, Murali. Very warm greetings, best wishes for the new year, and welcome to the all-year, always online AI for Good Global Summit. Today, we will discuss how we advance towards responsible AI for disaster risk management. We continue the conversation we started by our webinar on the 13th of October 2020 on the International Disaster Risk Reduction Day. That first webinar was extremely well attended, evidence of the importance of this topic and the strong commitment worldwide to achieve new breakthroughs with the help of AI. The participants in that first webinar were quick to act on the great potential identified then. On the 18th of December, ITU and its partners, WMO and UNEP, launched a new focus group on AI for national disaster management. The proposal to launch this focus group was greeted with unanimous support, and I'm very much looking forward to welcoming you to the first meeting scheduled 15 to 17 March 2021. The ITU focus group is open to all interested parties. We aim to bring together every stakeholder in disaster management and AI. We also wish to have a diverse and inclusive leadership and participation. I very much encourage you to act as ambassadors for the focus group by inviting like-minded experts to join our work. This multi-stakeholder initiative will be supported in close collaboration by ITU, the World Meteorological Organization, and the United Nations Environmental Programme. We are very appreciative of this support and partnership. This group is well positioned to achieve meaningful impact. In our first webinar in October 2020, we discussed the concept of disaster risk reduction in the context of AI. Today, we take it further and delve into disaster management as a holistic strategy involving disaster risk reduction, preparedness, response, and recovery. Pre-disaster forecasting as well as post-disaster responses are based to a large degree on data-driven insights. Inefficiencies in data collection and processing can have serious consequences, adversely impacting the speed and effectiveness of interventions to save lives. I mentioned data collection and processing because this is the basis on which AI could create new efficiencies. And this is the key to the work of our new focus group. ITU develops international standards and related guidelines to help countries apply information and communication technologies to maximum effect in support of disaster management. Our new focus group builds on a well-established body of ITU work But AI is introducing new dimensions to this work, and this focus group is set to accelerate these studies. Embracing ICTs in the context of disaster management will also generate boundless volumes of crisis data from a wide variety of sources. This highlights the importance of prioritizing valid information very quickly to ensure rapid and effective interventions. AI can analyze large volumes of complex and fragmented data to generate useful information. This can help governments and disaster relief agencies make well-informed decisions and set priorities effectively during an overwhelming crisis. We see the potential, but we also see risks to be mitigated. The application of AI in disaster management must overcome challenges such as algorithmic bias and related data classification disparities, false positives, and data generalization errors. Adversarial debiasing and explainable AI are among the concepts that could help us overcome these challenges. And in today's webinar, we are fortunate to welcome an excellent lineup of speakers and diverse expert audience to explore these and other key concepts in depth. I would like to thank our moderator, Younes Morali, as well as our speakers and participants for your contribution to today's discussion. This discussion is certain to deliver actionable insights that we can take forward together in our new focus group. Thank you very much.
Thank you, Bilal, for this kind remarks. And indeed, our session in October, which laid foundation for this current session, was very well received. And I'm also very happy that it has led to the formation of the focus group and is looking forward to its first meeting. Thank you, Bilal. I would now invite Dr. Monique Kublesh, who is the Innovation Manager at the Fraunhofer Institute. Dr. Monique is also the chair of the newly established ITU WMO UNEP focus group on AI for natural disaster management. She previously managed operations for ITU and WHO focus group on AI and health, a very successful initiative. In her past role at the American Meteorological Society, Monique was the lead technical editor for several journals, including the Journal of Hydrometeorology and Journal of Physical Oceanography, and the Senior International Outreach/Communication Specialist. As a researcher, Monique has investigated past climate change, extreme weather events, and regional climate model predictions. Monique has experience in fluvial and limnological fieldwork, geochemical laboratory methods, applied mathematics and statistics, greenhouse gas emissions, and climate risk impact research. Monique, you have the floor.
Hi, thank you, ITU and UNEP, for organizing this event. Thank you for the kind introduction, Morali. Again, my name is Monique Kublesh. I'm the Innovation Manager at Fraunhofer Heinrich Hertz Institute in Germany and chair of the new ITU WMO UNEP focus group on AI for health, for natural disaster management. The AI for Good webinar on how can artificial intelligence reduce disaster risks in countries, which was held on the 13th of October 2020, attracted an unprecedented number of viewers. This overwhelming participation, which is also mirrored today, reflects the importance of this topic to many experts and stakeholders and the widespread interest in exploring AI as a tool to support natural disaster management. This webinar also inspired the creation of the new focus group. Now, natural disasters are damaging physical events of predominantly natural origins, so they can be atmospheric, hydrologic, geophysical, oceanographic, or biologic. And the costs of these events can include mortality, injury, displacements, damage to property, including cultural heritage and infrastructure, as well as disturbance to nature and natural resources. In fact, between 2005 and 2015, 1.5 billion people were impacted by disasters, with 700,000 lives lost, 1.4 million injuries suffered, and 23 million left homeless. The situation is particularly acute in certain regions, such as small island developing states and least developed countries, and for certain populations, such as women, children, and individuals in vulnerable situations. Furthermore, these adverse effects are anticipated to grow through the combination of population growth, rapid urban development, and the growing frequency and intensity of certain types of natural disasters, in particular those related to atmospheric, hydrologic, and oceanographic processes. As a result of these widespread and diverse impacts, which directly or indirectly touch many of the SDGs, natural disasters are targeted in the activities of multiple UN offices, such as UNDRR, programs such as the UNEP, and organizations like the WMO. To minimize the costs and enhance preparedness for and response to natural disasters, the ITU has partnered with the WMO and UNEP to establish the focus group on AI for natural disaster management. The focus group will explore the potential of AI-based algorithms to support data collection and handling, the modeling of past and future events, such as reconstructions, forecasts, and projections, as well as effective communication. Now, during the webinar that was given in October, Bilal Jamoussi underlined the importance of working together to overcome limitations of data gaps, data reliability, and to improve the overall data readiness of countries for disaster prediction and monitoring systems. And I think we can all agree that high quality data are the foundation for understanding natural disaster processes, as well as the underlying mechanisms, for providing ground truth and calibration data, and for building reliable reconstructions, forecasts, and projections. Therefore, the focus group will look at how AI-based algorithms can be used to generate data, to monitor data, and to improve the quality of existing data. Specific considerations include, how can AI be used to enhance data quantity? For instance, how can AI be used to identify objects, such as tension cracks on a slope, and monitor changes in those objects from remotely sensed images? How can AI be used to enhance data quality? For instance, how can AI contribute to denoising or identifying inhomogeneities in instrumental time series? How can AI be used to support the detection of features in real time, such as earthquake signal detection and seismic data? And how can AI be used to leverage synergies from different data sources most efficiently? Now, at Fraunhofer Heinrich Hertz Institute, we have considerable experience working with time series and image data and have developed deep neural networks for specific problems in this field. To provide a few examples, in an ongoing project called AI-based Information Platform for the Localization and Simulation of Hotspots for Innovative City and Traffic Planning, we've partnered with the City of Leipzig, among others, to develop a platform that combines swarm sensors with AI to identify urban heat islands in real time and simulate future events. And another project that should soon be launched, data and AI-based early warning system to stabilize the German economy. Small and medium-sized enterprises, universities, and non-university research institutions are joining forces to develop a versatile AI-based model that can provide early warnings for hazards, including floods, storms, and heat waves. The focus group will also look at how AI-based algorithms can be used to enhance and improve the traditional models used to develop reconstructions, numerical-based forecasts, and physics or data-driven projections of natural disasters. Specific considerations include, what is the current gold standard method to create such a reconstruction, forecast, or projection? And how can AI-based algorithms bring these methods to the next level? What requirements should data meet when we train and test an AI-based algorithm? For instance, the quality and representativeness of training and testing data, ethical considerations, etc. And what should be considered when we evaluate an AI-based algorithm? How transparent is the model? How generalizable is the model? How adaptable is the model to new data? How uncertain is the model? And what is the best metric to evaluate the algorithms and performance? And at Fraunhofer Heinrich Hertz Institute, we're making strides in the areas of explainable, trustworthy, and robust AI, as well as improving measures to quantify uncertainty and evaluate performance. And finally, in the context of effective communications, the focus group will look at both technical aspects as well as social or policy aspects. For instance, once a natural disaster has been forecast or triggered, how can AI assist with the immediate response? for instance, early warning systems, push messages, or automated translation services? And how do we ensure that communication methods are reliable and trusted by the population? Are they accompanied by a clear set of protocols to ensure that individuals know how to respond? So to address these topics, the focus group is building an interdisciplinary, multi-stakeholder and international community with special effort made to support participation from low and mid-income countries and those countries shown to be particularly impacted by these types of events. Now I've saved the best for last, and that is, how can you join the focus group? So I kindly request that the colleagues at ITU post the focus group website into the public chat. There you can register for our upcoming meeting on the 15th to 17th of March, as well as join our mailing list. The focus group is free and open to anyone who is interested in contributing, and I look forward to your participation. Thank you very much.
Thank you, Monique, for the very brief and crisp remarks. I learned something that AI could also be used to generate more quantitative data, which in a way is also the fundamental to good AI. Very interesting. I would now invite Cameron Burns, who is the Senior Program Manager for Humanitarian Partnership at Microsoft. Having joined Microsoft Philanthropies in 2016, Cameron Burns resides in Seattle and manages how the company responds to sudden onset humanitarian emergencies through the provision of resources to responding agencies. In addition, he also works with nonprofits in the application of transformative technologies to address humanitarian challenges through such programs as the AI for Humanitarian Action, a 5-year, $40 million initiative which he manages. Before landing at Microsoft, he was with the United Nations World Food Program for 10 years, working predominantly in South Sudan, which was preceded by 5 years with the US Army. Cameron, very interesting work. We are looking forward to hearing from you. Over to you.
Great. Thank you very much for the kind introduction, and thank you to ITU for the opportunity to be here today and with such an esteemed panel and share our work. As was mentioned, I am with the Microsoft Philanthropies team, and so we are a business unit within Microsoft, dedicated and focused on providing resources to response organizations in the area of humanitarian assistance, and that's specifically the work that I do. As part of this, as mentioned, I run the AI for Humanitarian Action program. This program is one of 5 sisters under our overall AI for Good portfolio, which includes things like AI for Health, AI for Earth, AI for Cultural Heritage, and AI for Accessibility. In the program that we run, we are focused on the humanitarian aspects and how AI can be applied. Specifically, we have 4 pillars in which we support projects, and those are human rights, the needs of women and children, refugees and displaced persons, and disaster response, the topic that we're discussing here today. Over the last 2 years, we've completed 25 projects with humanitarian organizations, nonprofits, and UN, and currently have 14 underway. We had an open call during this last fall, during October, and are now undergoing those, are now investing in those projects as we move forward. When we do this in the work that we do, our approach is very specific on that partner and organizational enablement. Means we are looking to come to the table with resources that we are good at, which is our technology and our people, and to help organizations that are looking to apply AI in one of these key areas to develop the models that are, and to develop and deploy the models that they need to be successful. It is very much about that partner. We are looking for, they control and own their data, and we build models that they own and deploy. This is all for their deployment and implementation and their ownership. These aren't something that we claim back as Microsoft. We're just looking to enhance the responsibility and capacity of these organizations. Now, when it comes specifically to disaster response and preparedness, we definitely believe there is a role for AI to play, as many on this call also believe. And there's a couple different areas that we've been looking at, especially with some projects that we have underway. And there's no better way to really sort of exemplify what I'm talking about than to dig into some of the projects. So for example, right now we have one large investment, in the country of India, and that is about both response and mitigation. Specifically, the business challenge that was being faced is there are households of high need, particularly low income, but they might be in areas of higher income. So while you might have a generalized understanding of the different abilities and resilience of a household by an area, how do you find those individual ones that might be below on the scale? And so right now we're working with a nonprofit on satellite imagery analysis to identify the roof types as a proxy indicator for household wealth, and to do two things. One, for when, in this case, a typhoon hits, to allow to target response by households, and also for resiliency planning to ensure that when the organization goes in and is working on planning with the folks, that they get they're better prepared than the assistance they need. Other areas that we're seeing a lot of success is around that satellite imagery component. It is that labeling and then taking those data labels and then building the models off it to assist in that response element. And that's really what it's at, is how to get people to do their work faster with more insights. Instead of all the manual labeling what takes place, not replace it, but help speed it up. This is a large investment. For example, we did the humanitarian OpenStreetMap team that, for those who are familiar, has tens of thousands of volunteers around the world to help with data labeling for areas of high humanitarian need. So we're helping them do is deploy models that speed up that human element, which is very key here. Going back to the earlier topics about how do you do risk mitigation, how to ensure you do appropriate AI deployment, that's really how our approach has been, about helping the humans that stay in the loop do their job better, faster, and more efficiently. Some other areas too that we have seen some success too, actually the boring stuff. Our largest impact happens on also the operational side. We have a large nonprofit within the United States. Their business challenge was they deploy hundreds, if not thousands of volunteers at times of disaster. And while they try to maintain an accurate roster, they really get that surge of people coming in and trying to raise their hand and volunteer. Well, those need to be validated. So they would have human resources team that would be crushed trying to process paperwork to get volunteers out the door and deployed. So for instance, there, it helped them with a model that allowed them to validate some of the certification paperwork required and automatically update the HR records. So the humans can focus on what humans are good at, which is assigning them to basically getting them out the door and getting them assigned to teams. We obviously see challenges in this sector. This is not the easiest place to, the easiest field to be working in. And the biggest one too is data. Unbiased, good, clean, trusted data. We see that is a difficulty that happens and stuff that we're helping organizations to mitigate. It does prevent some of the sort of expectations around AI from being fully realized. But there has been a lot of growth. We've seen a lot of maturity in the sector in the last few years, which has been fantastic. The other thing too is for organizations to understand their responsibilities when they request for AI models and assistance. That is how you have to ensure you sustain, train, and monitor these models. Now, and then what do we have going forward? Well, we are getting excited, and where we're looking to really make investments too are a couple areas, is open data and consortium-based and data sharing projects. We really want to see the sector publishing the data out for others to utilize. Any investments that we make now around data labeling or creating data should be published. We want to see others building off it and really bringing a lot of effort to the sector. And then for the projects we want to invest in the future, we really want to see consortium based with data sharing taking place. Get out of the individual organizations. Show how with your peers you can come together and really bring large groups together for that impact. And so we will have an open call taking place in the spring, and these are the kind of areas that we'll be focusing on there. So with that, I'm happy to answer any questions later on as we continue the panel or in the chat. Thank you very much.
Thank you, Cameron, for your excellent intervention. You also mentioned the importance of data sharing and the potential to form data consortiums. I think that's a very important aspect as we move forward. I would now call upon Mr. Anthony Ria, who is the Director of Infrastructure Development at the World Meteorological Organization. The department covers global coordination of observations, data exchange, and modeling across domains of weather, climate, water, oceans, and cryosphere. Dr. Ria has a PhD in satellite meteorology from RMIT University and a Master of Public Administration from Australia and New Zealand School of Government. During his PhD studies, he worked on operational satellite applications in the Australian Bureau of Meteorology, including sea surface temperatures and atmospheric motion vectors. Subsequent to this, Dr. Ria undertook a variety of roles in the Bureau of Meteorology as National Manager of the Observations Program, where he led a significant organizational change, and in the corporate area where he was responsible for government relations and communications. Immediately prior to joining WMO, he was the Chief Data Officer for the Bureau of Meteorology. Anthony, you have the floor.
Thank you, Murali, for that very comprehensive introduction, and thanks very much to the ITU for the opportunity to speak to you today. I speak to you as a data person, maybe rather than an expert in AI, but hopefully I've still got some insights for you during this very interesting session. So WMO, for those that don't know, it's a specialized agency of the United Nations, and its mission is, amongst other things, to facilitate worldwide cooperation in the delivery of meteorological services, to facilitate the rapid exchange of meteorological information, to advance the standardization of meteorological data, and to foster cooperation across domains. So WMO operates across the domains of weather, climate, and hydrology, and we work to build interoperability and cooperation across those areas. So firstly, how do we, I'll come at this from a weather and climate perspective, I think, because that's the types of disasters that we're are in our remit and that we're interested in. So how do we project weather and climate? And I guess, what's the role of AI there? So we forecast the weather using really large computers, supercomputers, moving into exascale computing these days. These are huge pieces of national infrastructure, and there are roughly 12 centers globally that run models that cover the whole globe and project out to sort of the 7 to 10 day time frame. These models, the most advanced models, are running at 9-kilometer resolution over the surface of the Earth, which it doesn't sound like a lot, but it's a huge volume of data. We're dealing with petabytes of data on a daily basis. There's experiments being run to try and resolve higher resolution phenomena at 1 kilometer resolution globally. But just know that weather forecasting, it's a global problem to forecast the weather out 7 days in advance. You need to understand what's happening right now. So we also coordinate a global program of surface-based observations and of satellite observations. And the models that we use merge together data from more than 30 satellite sensors and from weather stations, ocean observing platforms all over the planet. So this is a big part of WMO's role here, and one of the important things that we do is that we set the standards for international data exchange. So what data has to be exchanged, what are the formats, down to what are the kind of ontologies and so on. How do we actually describe the data that we're using? So once again, what role does AI play here? Well, it's not going to replace those weather models. These are built on physical understanding and decades of research into how the atmosphere and oceans interact and how this plays out into the forecasting of the weather. One of the things that we need to guard against, I think, in the use of AI is to think of it as a magic bullet. And we've seen many examples, I think, where an organization or an agency or a company has access to a specific data set And then they make a decision, oh, well, we're just going to vertically integrate and run this through AI and generate forecasts or warnings for the public. No offense to those people, but we can do that a lot better by bringing together a whole bunch of different data sets in a physical model often to generate forecast information. So we use machine learning and artificial intelligence, I think, in situations where maybe we don't understand the underlying relationships. Maybe we don't fully understand the physical basis of what's happening. There are plenty of places in our area of science, in our area of service delivery, where that is possible. So, for example, Cameron talked about using image interpretation and so on, and I think this is one area where we can look at the pre-processing of observations. So before they go to their models, looking at a specific observation, maybe comparing it to a background field or to its neighbours to understand whether it might be a good or a bad observation, because bad observations make our forecast worse, good observations make our forecast better. And so that's absolutely one area. And another area might be, for example, in bringing in new types of data from crowdsourcing type algorithms. So we have many sensors, the Internet of Things, people's mobile phones and so on, where we can gather a wealth of additional data. But perhaps building on something that Cameron said, I think one of the big areas of potential impact is in decision support. We live in a data-driven age, and weather forecasting is no different. Historically, we've had weather models generating products that are interpreted by weather forecasters, and then services are generated. We're in a state where the amount of data coming to the forecasters, both from the models, from real-time systems like satellites and weather radars, it's overwhelming, and it can't be dealt with by an individual in a kind of efficient way. So we can use AI to recognize where there might be a severe event happening or a severe event developing or the risk of a severe event, and use that in a decision support mechanism to make the forecaster more efficient and allow them to do their job better, and maybe allow them to pick up things that they couldn't otherwise pick up on. So I think this area of interpretation of results and decision support is a really important one, and we can think about interpretation of model results. We can think about image interpretation of weather radar data and of satellite data to, for example, to pick up on tornado signatures, or to pick up where there might be severe precipitation going to occur. Another area, I think, and this is where we get out into the broader community in terms of impacts. So I think if we think about what WMO is responsible for, we talk about what the weather is going to do, but really in terms of DRR, what we're interested in is what's the impact of that weather on an individual or on a community. To do this, we need to have additional data that comes from outside of the weather community. So information on the built environment, information on population, perhaps health data if we're talking about something like heat waves and we want to understand the vulnerability of a population. So to enable AI to create an environment where AI can thrive, data needs to be open and available, and it needs to be interoperable. We need good sources of data for training data sets, and in particular on the impacts of past weather events, so we can use those to train algorithms to understand what the impacts of future events might be. We need to understand where AI and machine learning can help, and where we're better off taking the approach of a physical model, and there are many examples where that's the case as well. So data curation is really, really important. In my experience in using large data sets and in doing data science, and I think this is reflected by many people, 90% of the work can be in curating the data and QCing the data and making sure that the data is ready to feed into your algorithm. We're trying to create a situation, we'd like to work with the international community to create a situation where these data sets are available, they're open, and they're accessible, and most importantly, they're interoperable, and they're using the same kind of language to describe phenomena. There's a lot of work involved in this. It doesn't come easily. So the best way to enable AI in DRI is to ensure the data is available. We need to be careful. We get into the area of personal data and sensitive data as well. And so once we start talking about health data and demographic data, we need to also be mindful of privacy considerations and ethical considerations as well. And the data that's available needs to be appropriately anonymized or otherwise masked so that we can't get down to individual private information. And that is also a very tricky area. So
you have 1 minute.
I'm going to finish up now. Thanks, Murali. So in closing, I just also mentioned that WMO is undergoing a revision of its own data policies. WMO has been committed to the free and open exchange of meteorological data. We have a new data policy going to our WMO Congress late this year, which will restate that commitment, that strong commitment to making our data available to the broader community and not just the meteorological community. Thanks very much for your time. I hope to get some questions. Thank you.
Thank you, Anthony. I can promise you that you have more questions than what we can take. There are so many questions coming into the Q&A box. So the speakers and also many other experts who are already on the platform, please feel free to answer those questions in real time. Anthony, it was very good to know that WMO will be coming out with a data policy, because I think we must all have, all the UN agencies, but also all the countries and organizations should soon have their data policies. Unless we have it, I think the AI machine would starve of data. Thank you. I would now invite Mr. Yasunori Mochizuki, who is the NEC Fellow in NEC Corporation. He's a fellow since 2019 and is now engaged in digital transformation and Internet of Things ecosystems strategy for small cities. Previously, he was Senior Vice President responsible for NEC's corporate technology strategy, managing R&D roadmaps, standardization, and open innovations. He has 30+ years of career as a research scientist and then as a general manager of research department, and his technical expertise covers a broad area including AI-oriented computer science, ICT systems, integrated devices, and solid-state physics. Yasunori, you have the floor.
Thank you very much for the kind introduction. Of course, it's my great honor to be on this webinar. So already the previous speakers covered a very comprehensive overview of both from technical as well as the humanitarian and societal aspects. So what I want to do is to a little bit change the taste of the intervention, tell something about more on the ground level, experience-based, something specific, along with some context from a country of Japan, which is heavily impacted by natural disasters. And also I will talk something about the perspective on the responsible use of AI technology. And we are living in a world where natural disasters are intensifying. Climate change is resulting in torrential downpour and hyperscale typhoons, and human-related factors such as urbanization and deforestation are also making the disaster risk even bigger. And NEC is offering a variety of solutions to support the activities of disaster handling agencies. And today, many of them leverage various types of AI technologies. So here, I want to pick up two specific example use cases, SNS analysis and crowd behavior analysis, because I wanted to focus on resident and local government agency aspect, as saving lives is at the highest priority, whereas people become suddenly chaotic and confused under the disaster situation. Okay, on March 11, 2011, Tohoku earthquake and tsunami hit Japan. Communication service went down suddenly due to the serious damage to the infrastructure. Internet was not completely dead, but at a very limited quality. And it was a time when we came to know the power of internet services, which played an unprecedented role in such a tragic and chaotic situation. Twitter played a crucial role in sharing local information on food, doctors, blackouts, and so forth, and the local governments also relied on Twitter for information transmission. And we're talking about NEC's SNS analysis. Our solution allows a real-time situation understanding and visualization by analyzing tweeted text and supports disaster agencies' quick and right decision-making and prioritization of actions. You can easily imagine that tweets are challenging language for computers to understand, and the context is heavily compressed and expression varies from one user to another. And it is for this reason that most advanced class of natural language processing AI in the disaster domain was developed. The solution is based on the earlier research outcome of a National Institute for Communication Technology of Japan called DISANA and DISAM, which was then further enhanced by NEC's machine learning for accuracy. Now, whatever the daily planning and drills are in place for agencies and residents, disaster attacks a region all of a sudden, often in an unexpected way. And the first action needed is to correctly understand what's happening, which areas mostly heavily damaged, and who are in need of immediate rescue. Our solution extracts such information from the tweets and also integrate relevant information provided by public agencies, and it gives a bird's eye view of the situation, displaying the analysis results on the geographic dashboard. There was a wild downpour last July in the western part of Japan when 65 lives were lost. The flood broke out in the nighttime, but the analysis correctly showed the three most hazardous cities along the major river. Another example for Chiba Prefecture that is located right next to Tokyo. There was a blackout caused by a wild typhoon, and the government immediately knew that this blackout was very serious and entirely prefecture-wide. So the SNS analysis can make the agency immediately understand what kind of damage has been most serious, with what spatial extent, and which is the area where people need immediate rescue. Now, Tokyo is 350 kilometers away from Tohoku, but the vibration of the Tohoku earthquake was still enormous also in Tokyo, and all the public transportation stopped on that day. And we saw something we had never seen before. People trying to walk home filled the downtown area, and the emergency vehicle no longer able to run on the streets due to deadlock. So out of such tough experience, a municipality called the Toshima Ward in downtown Tokyo decided to implement NEC's crowd behavior analysis in order to enhance readiness to anomalous situation taking place in the downtown area. This solution leveraged video analytics AI that is based on some special machine learning technology. From the real-time video stream of cameras observing the downtown streets, our technology doesn't identify individuals, but instead analyzes the crowd dynamics and accurately quantifies local human density and local flow vector, and gives a warning when some early trace of unusual situation is discovered on the streets, such as overcrowding and people's stagnation. This analysis is useful not only for natural disasters, but also for other urban incidents, such as fire. And it is 2021 now, and I want to discuss disaster management under pandemic situation. NEC is a top-level technology provider for face recognition AI, and we are seeing this technology has started to play an increasingly important role in the last several months. NEC solution called One ID, which leverages consent-based face recognition, was adopted by Narita International Airport, originally before the pandemic to enhance passengers' experience of going through multiple checking processes, by far faster and more comfortable as compared to paper and staff-based check-in handling. But now, under COVID-19 pandemic, we are offering face recognition-based solutions also as an enabler of social distancing and touchless operations. So in some future, such a capability may turn out to be also valuable for shelter operation management under disasters. But of course, there has to be an appropriate governance mechanism of ethical and responsible use of such a human rights sensitive technology. NEC believes that a multi-stakeholder approach is necessary to build a transparent framework for such a purpose, and we are undertaking a collaborative effort with a broad range of customer agencies as well as academia and legal experts. A recent example is the governance toolkit for responsible use of face recognition with audit and certification framework that was developed and launched last year by World Economic Forum, which was then actually piloted under the collaboration with Narita Airport Agency. Now, what I explained as a use cases so far leverages AI for recognizing and understanding what are happening under the disaster situation, which will probably bring the most immediate and high priority value to disaster handling agencies. But future solutions may also provide more management-oriented support, for instance, to logistics and recovery task optimization. For such a type of solutions, NEC is proud to be in the leading position in developing what we call the white box AI, also known as explainable AI. Now, whereas typical deep learning technology doesn't tell us why a certain result was obtained, the white box AI is not only gives not only the prediction and recommendation, but also the set of quantitative reasons why the AI reached the given conclusion. And we believe such a white box AI approach makes another important contribution toward the responsible use of AI from the technical approach. Many kinds of deep learning has been applied to problems with a clear single goal, such as autonomous driving. The requirement here is the overwhelming speed, accuracy, and automation, and such an AI plays the important role in alerting and understanding the disaster situations. The other class of AI is to support humans' management and decision making, for which problems do not usually have a clear single goal. And this is where the white box AI or explainable AI approach is very useful as the enabler of a transparent and responsible use of AI. So it is not that one AI technology fits all. It's very important to combine both of these two approaches in order to fully leverage the potential of AI towards more inclusive as well as comprehensive disaster risk management. And thank you very much.
Thank you, Yasunori-san. It was part of the UN team which came to Japan after the Tohoku earthquake, and I'm very happy to learn that when during those crises, you did manage to do things, but also learn from it. I also take note of the concept of the white box AI as against the black box AI, which we are all used to. I think it will be increasingly important that AI is able to explain the decisions transparently so that those who use or are subject to the outcome of these black box technologies would know why those decisions were taken. Thank you.
Thank you very
much.
much.
We now have the final speaker of the day, Dr. Rakesh Barhania. He is the Director of Humanitarian Impact Data at Salesforceorg. Rakesh is responsible for defining engagement with the humanitarian community, focusing on the principled, safe, and ethical applications of innovative technologies in humanitarian contexts. He has spent more than 25 years in the humanitarian sector, focusing on the intersection of emerging technologies and international humanitarian crisis response and development. Some of his past work includes responding to the September 11 attacks, Hurricane Katrina, the United States, the earthquake in Haiti and Japan, Super Typhoon Haiyan in the Philippines, and Ebola response in West Africa. Prior to Salesforce.org, Rakesh worked on privacy engineering team at Apple, focusing on EU, global data protection regime compliance, and related policy and engineering work. And at Cisco, where he helped to create one of the earliest private sector humanitarian technology response team. Rakesh, you have the floor.
Thank you so much. And thanks for the introduction, and thanks for the invitation of the ITU to present today. And again, thank you to all my co-panelists. There's been some really interesting conversations that I've been taking note of. Just to introduce my organization, Salesforce.org is the social impact center for Salesforce. And I work specifically with the international humanitarian and development community to accelerate their impact by increasing their use of data and evidence in the service to these critical missions. Now, at Salesforce.org, our starting point for engagement with the humanitarian community is to recognize the first principles of the humanitarian community. So humanity, neutrality, impartiality, these are common phrases in Geneva. They are less common in Silicon Valley. And so we aim to start by recognizing that data is ultimately always about people, and data is always about power. And that's true whether we're talking about data about specific human individuals or whether we're talking about machine data or other sort of more abstract forms of data. Ultimately, all data can be tied back to people. Now, technology people, like those of us here in Silicon Valley, are sometimes accused of what is sometimes called solutionizing, which is rushing to put a new technology into play without understanding the problem first. How many times have you heard blockchain being used for everything? So I think that one of the first tasks as we go into AI in disaster risk reduction is to actually understand the problem space. And so I think a good start point here is to understand the Sendai framework. So the Sendai framework came out in 2015, and there are 4 major pillars and 7 targets. And they include things like reducing disaster risk, reducing global disaster mortality. And then they also support the increasing of capacities and, for example, increasing the availability of alerting and warning systems and communicating DRR information. Now, I think that this last one's really kind of interesting because, as we all know, alerting and warning systems must have essentially 3 practical functions. They must be timely, they must be accurate, and they must be actionable. And if any of those 3 things is wrong, then in many cases, you're going to create more confusion and more chaos rather than lessening confusion and lessening chaos. And so what I'd like to do is kind of run over some of the areas that we see that AI probably makes sense. So things that AI, and we say artificial intelligence, but I think that right now it is perhaps more fair to call it augmented intelligence. Things that AI does best right now are things that don't require a deep level of contextual knowledge or common sense about a particular problem space. AI is really good for problems, as was mentioned earlier, where data are plentiful. So if you have a lot of data about a particular problem, then AI is certainly arguably much better than having humans going through that same mountain of data. AI can do very well in answering questions where there is a clear right answer. So places where there are gray areas or ambiguous answers are less well suited to this. And so we find ourselves leading towards essentially high volume or low stakes decision making. And then the last area is certainly at Salesforce, where our AI platform known as Einstein is integrated into our products, is in the decision support area, or recommending next best actions. And Anthony said this earlier in his presentation, that even at the individual call taker level or individual human level, being able to present that next possible best action is often a good way to nudge people towards good decision making. Now, there are obviously risks. Cameron mentioned data availability and quality. I would certainly echo those concerns. I think everyone actually has mentioned some version of that concern. I think another area that we see in the humanitarian sector that's a challenge is scaling from proofs of concept to something mature and actually usable. And then to actually have relevant use. And we saw some of this with the COVID-19 outbreak earlier last year, about a year ago, where if you recall, rewind your mind to about a year ago, a lot of technology projects related to COVID-19 kicked off, but some of them had more impact potential than others. Some of them actually were more relevant than others. And I recall seeing a solicitation for people to train an AI model that wasn't expected to actually help with COVID-19, but was intended to help with the next pandemic or the next disease crisis. And when you are dealing with an urgent emerging circumstance like the emergent pandemic, if you're thinking about spending your time working on a project that is going to have immediate value versus one that is much longer term or more research oriented, you have to think about where you want to spend your time and where you want to spend your resources. And people who think that they're training an AI model for immediate crisis response may be sorely disappointed to find out that their efforts are actually not relevant to the needs at hand, but are intended for some future product. And I think that we think that data for prediction is objective, right? But it's not. In 1994, there was something called the Great Lakes Refugee Crisis in Zaire, in Goma, related to the Rwandan genocide that same year. And in that circumstance, there was essentially a sampling error. The media parachuted into a certain part of the refugee area, there was about 2.1 million refugees displaced from the genocide. And wherever the world's cameras were, where the NGOs went, where the humanitarian community went. And so huge swaths of needed, population who really needed help never got help because there was essentially a bias in the sampling. We, the collective humanitarian community only went to where the cameras were and ignored everything else. And so we need to recognize that data for prediction is not objective. And the last challenge, and I say this as someone who works in a high-tech organization, one of the things that I am concerned about personally is I am seeing humanitarian organizations getting very excited about these new and innovative technologies, and that's all great and grand, but then ceding all the power questions, all the hard go, no-go questions to the technology community. And while my friends from the technology community here on this panel and around the industry are absolutely happy and thrilled to be supporting your missions, they aren't our missions. So one thing that I would really challenge the humanitarians in the audience here is to really own the hard questions about go, no go on these problems, and to make sure that you're not ceding that power and that agency to your technology partners. Now at Salesforce, we make sure that we are focused on the ethical use of AI. This is obviously an important issue for the industry. And so one of the things that we did was we created the first Chief Ethical and Humane Use Office in the large technology company industry. Yasunori-san mentioned human rights concerns, and that is certainly our point of view as well. We start with a human rights-based lens. And some examples of where we've seen predictive work in humanitarian contexts. In 2017, UNHCR in Zimbabwe piloted an algorithm to do migration crisis prediction. It was based on population growth, extreme weather incidents, GDP growth, and a number of other things. And it was able to use historical data and then bring in real-time information. And it was to see whether it could actually predict a migration crisis. Now, that pilot was to then scale up to recommending next best actions, such as suggesting remedies to mitigate an impending famine by recommending updated farming practices, for example. ESA, the European Space Agency, in 2020 published a paper predicting using AI to predict cholera outbreaks using climate data. Now, so most of the cholera outbreaks in the world happen in the northern Indian Ocean region, so basically South Asia. With this example, for example, the cholera outbreak, being able to predict it with 89% fidelity, and UN SPIDER, United Nations Office for Outer Space Affairs, is looking at using AI to help predict the occurrence and timing based on timing and size of earthquakes, using 700,000 earthquakes in Japan and California. There are many, many, many possible applications of AI in humanitarian affairs and in disaster risk reduction, but it's going to be a collaboration between the private sector, who technically are the technology experts, and the humanitarians and the people like yourselves who have the mission to come together and actually focus on determining what the right applications are, and to do so in an ethical and an effective and impactful manner. Thank you so much.
Thank you, Rakesh. It is extremely interesting, useful, and satisfying to know that we actually have an ally in the Silicon Valley, having experience in the humanitarian side and now sitting on the technology side. And you are absolutely right about the bias of the humanitarian agencies ending up where cameras are, and the opposite also happens occasionally. Thank you. So we have now completed the first round of presentation. As you would have noticed, there are many questions. We have tried to answer some of them. We'll try to answer more. But in the meanwhile, I would ask the panelists some of the questions which has come up. I'll start with Monique. Monique, you have been involved in the AI for Health focus group as well. What are the similarities and differences you see between the AI for disaster risk management and the health? And if you could also explain how people who are listening to this could get involved in it briefly. Thank you.
Gladly, thank you for the question. So I expect to see some parallels between the two focus groups. Both have an interdisciplinary, multi-stakeholder and international nature of their communities. Of course, in AI for Health, we worked mostly with people in the health sector, with regulators, ministries of health, et cetera. Whereas in the natural disaster management group, I expect working more with members of the geoscience community, government agencies which do emergency management, industry partners, those in insurance or reinsurance, logistics, transportation, and other types of stakeholders. But I do think that the common feature of both focus groups lies in this coming together of different types of people, different types of expertise, and different perspectives. I also think there will be some parallels in the content of our activities. In the focus group on AI for Health, there's been a lot of progress made on identifying the best approaches to handling and assessing data and AI solutions. And I'm sure that some of this information can also be applied to the natural disaster application. And just to mention, in case anyone is interested in the ITU WHO focus group on AI for Health, they're going to have a meeting next week and would be happy to have you join. Thank you.
Thank you, Monique. I will get back to you with many other questions. I have also noticed that you have been answering questions vigorously on the chat box and Q&A. I would now turn to Anthony. Anthony, you mentioned about the challenges of data quantity and data sharing and the new data policy coming up in WMO. My question is, how can UN agencies, private sector and academia start to collaborate on making this data available and develop the AI technologies? Because together we will have a lot more access to data and we can grow much faster. Do you have any plans or suggestions on this matter? Over to you, Anthony.
Thanks, Murali. It's a good and it's a provocative question. I mean, within the WMO, in terms of AI, we have a scientific advisory panel, and that operates on the horizon of 5 to 10 years. So what technology is coming down the line that WMO needs to be thinking about, and with that, part of that is AI. So there's a piece of work and there's a white paper being developed on the future of AI in meteorology, climate and hydrology. In terms of how we build the coalitions, I mean, I think this is a really good question, because as I said in my presentation, to really understand the impacts of events and to get that information on the impacts to the people that need it, we need to work across sectors, and we need to work across both government and the private sector. We've been working hard. We had a declaration last year, the Geneva Declaration it's called, but it's really about engaging the private sector in our work. So we are involved with equipment manufacturers. We do some work with the weather company and other kind of big tech companies who are also interested in the weather space, and we're interested in pursuing this more. From our perspective, we try and make our data as available as we can, and we hope that will generate reciprocal actions from others. But clearly, we need to do a little bit of advocacy and a little bit of reaching out across the different communities. We can't continue to operate as a kind of little bubble of weather and climate experts. So I don't have a good answer for you, but we are working on this, and we'd like to expand the connections that we have in this area. Thanks.
Thank you, Anthony, for that. I think it's going to be a work in progress. I would now turn to Yasunori-san, and as you may have noticed, also in the question answer segment, there are a number of questions about data privacy particularly because you spoke about face recognition. So my question is, what are the key constraints faced by NEC in doing the type of technology work which you have been doing, particularly since because it involves face recognition and privacy concern? And how can UN agencies and government support and facilitate your work? Over to you, Yasunori-san.
Okay, so this is a tough question, not limited to natural disaster handling. AI will certainly bring good value, whereas this is also a concern from the government governance aspect. And filling gap is a very tough question. And also, as we move into the local government, which are in the position to procure such AI-based solutions, another challenge is that the immature digital literacy to handle these aspects. So actually, I'm personally working strongly with the organization called the World Economic Forum's Center for Fourth Industrial Revolution. And the only way we can do is to set up some policy roadmap. Technology is okay, but policy roadmap and the important defining the important pillars, including of course the transparency and privacy that are implementable to the local government level. And the way we do is to iterate such piloting to come up with the shareable policies. Policies set defined at each local government is difficult to work with from industry. So I think this is a major challenge, and I do believe I'm mostly working under the cap of a smart city. Smart city is a place where the verticals are implemented in one place, and in Japan, the disaster management the most attracts the highest attention to be implemented into smart city. So the working on the entire privacy and challenging issues from the governance perspective, I of course have a big expectation in the UN departments, and so you have also the departments like U4SCC and the UN Habitat, which of course shed light on the citizen human rights compatible way of using such AI and data sharing technologies, and that is the thought that I have at the moment.
Thank you, Yasunori-san. I will now turn to Rakesh. Rakesh, as I mentioned, you are an ally in the Silicon Valley. So I want to start by asking, are you an exception, or are more and more Silicon Valley companies having humanitarians in their organization? And whether with experts like you or otherwise, how do we ensure that the AI work and the AI partnership adhere and contribute to humanitarian values and response? Thank you.
That's a great question. Thank you so much. I would say that we are relatively few, but we are growing in number and in scope. So for example, a number of the organizations on this call are members of NetHope, nethope.org, which is a collaboration between the technology community as well as the large international NGO community. And that is a great convening space, and well, space is relative in a digital first world now, but it is a great convening area for these kind of conversations. And you're starting to see increasing numbers of the technology community. So if I look at the largest technology organizations in the world, and we're talking about the Facebooks and Googles and Microsofts and Ciscos and Salesforces, yes, they do have people who focus on this. And obviously, my colleague Cameron here from Microsoft plays that role for them, much like I play the same role for Salesforce. Now, but now the other thing is that it's not just the large technology organizations that are doing this, but a lot of the newer, smaller startup companies are also doing this as well as part of their social impact mission. So a collaboration called Impact Cloud, which is at impactcloud.org. These are a number of these next generation sort of cloud first technology companies. And they really came together in a collaboration to engage the humanitarian and nonprofit community through the Clinton Global Initiative about 5 years ago. And their collaboration is how do we as the technology community engage in deeper, more impactful ways with nonprofits of all kinds, not just humanitarians. So I think to answer your question, they are still relatively few and far between, but understand that the technology community in its core wants to give back. That's part of the ethos. And so you are starting to see in more and more of these kind of sort of bridge builders emerging within the technology community. And certainly from our perspective, we're very, very eager to work with all of you, including our colleagues in the mission space with the NGOs and the UN folks, as well as the academics in the audience. Thank you.
Thank you, Rakesh. I have a very interesting question from Kaglar Kunkor, who mentioned, I find it very interesting that whenever we talk about stakeholders, we refer to technological developers, government organizations, international organizations, natural scientists, and industries. And his question is, I very much wish the relevant organization consider social scientists also to be part of this development. So the question I would, at this point of time, probably pose to Monique and see, did you have social scientists included in the AI for Health focus group? And are you considering having them in the AI for natural disaster management? Monique.
Hi, thank you very much for the question. It's a great question. So it's sort of a multi-part question because you mentioned NGOs and social sciences as well. With regard to NGOs, we've already worked in establishing relationships with many organizations that are very deeply involved in this area, such as the European Geosciences Union, American Geophysical Union, European Meteorological Society, American Meteorological Society, Asia Oceania Geosciences Union. I could go on and on and on. So we're definitely keen on working with NGOs on this topic. With regard to social scientists, I'm absolutely happy to have their participation in the focus group to get this perception. I'm a physical scientist, so I'm always happy to hear another perspective. Yes, I mean, we had a very fruitful collaboration with an AI for Health, and I hope to duplicate that in our new focus group. So thank you.
Thank you, Monique. A question to Cameron, which is about, in what specific area do you see the greatest demand, since you are developing partnership? So the type of proposal you received would have given some indication as to the demand pull on AI technologies. Cameron.
Yeah, it's a great question. We're sort of right now it's sort of clumped in two areas. And I know right now these areas are not all encompassing, but for the last submissions that we've been getting, one is really that imagery analysis, not only from satellite, but also drones and other image capture, which is quite challenging. I believe Monique brought up earlier the discussion about generalization models and the challenges there, where they are quite difficult, especially when you start looking at these different things capturing images and how they present. The models have a hard time, but we're seeing a lot of requests on that, and we're trying to do work in that space. And the other is actually, I mentioned before, is those operational efficiencies. What I behind the scenes call the boring stuff, but actually has a huge impact on the organization. I'll give another example for one we have. It's not disaster response related. However, it's an organization that was just dealing with a huge amount of paper capture. They were working in institutions where computers were not allowed. Their caseworkers have to do a lot of handwritten forms. So we redesigned the form and deployed an image capture model that used that best, so that they really freed up all of that human time. I think that's where we're also seeing a tremendous amount of impact. And also that sort of work is also more approachable, understandable, and as raised by most of my colleagues, has that reduced ethical risk. Like operational efficiencies are easier to manage with that understanding, and also easier to mitigate some of the challenges you might have if a model for some reason had bias or was trained on inappropriate data. Easier for a human in the loop intervention. So yeah, I would say those are the two areas that we're seeing a lot of interest in and where we're making some investments.
Thank you, Cameron. Now, Anthony, you mentioned a lot about data availability and data quality. So one of the questions which has come up is that the countries probably which are greatest at risk are probably the one which have the least amount of data in an operable form and least reliable data. So what can we do to supplement those data with more high quality data from satellite image analysis? Is there some sort of a data gap analysis possible for countries in natural disaster management? Anthony.
Thanks, Murali. It's a great question, and it's very topical. We have been monitoring, I guess, one of the things that we do is that we monitor the amount of data that's available from different parts of the world. As I mentioned, weather and climate projection, it's a global science, and it requires data from all over the planet. But if there is a lack of observations in one part of the globe, that will have an impact on the forecast in that area. Satellites, of course, are part of the solution. You know, satellites, the great advantage of satellites is that the data is ubiquitous, it's everywhere, and in the meteorological community, largely it's free and open and available to everyone. We recognise, though, that particularly in the developing world and the less developed countries, there are large data gaps in terms of surface-based observations. We've got an initiative called the Sustainable Observations Financing Facility. We're working with donor agencies to develop this concept further. And what that would do would be to provide some financing to those countries that can't afford to meet their obligations on their own. You know, ideally, we want to get a kind of even coverage of observations over the whole planet, and where there is a gap, like large parts of Africa, for example, we get very few surface-based observations. We are working with donor agencies to try and fill those gaps, essentially, and this will improve both the global outcomes, but specifically improve the outcomes in those countries. And we've done some modelling, some economic modelling, talking about bringing in social scientists that show that the payoff for doing this is maybe 26 times the investment in terms of the economic benefits. So I think we can do these kind of things, and we can work across different sectors to try and close these gaps. Clearly, you know, the Internet of Things and handheld devices and so on will also open up observations in remote areas, and we're seeing some interesting developments in terms of low-cost space-based communications, which could mean that, you know, we can bring data from small sensors from some of these places much cheaper than we've been able to before.
Thank you, Anthony. So I would now go to Yasunori-san and ask, because you worked on the facial recognition software, you know, which has many potential applications beyond what you initially aimed at. And as you know, often the government or private actors could misuse such technologies. So our question is, how much of work on the ethics and security of the technologies you develop is involved in your market analysis and also your product development?
So internally, we have some governing organization called the Digital Trust Strategy Promotion Office, which takes care of such a kind of communication and the care that has been taken in making communication with the customers. And these customers are mostly for the private sector companies and the government. Also, we have the internal securing process of AI algorithm and the product quality. And but on the most important part still relies on the our customers' communication with the beneficiaries. For instance, disaster management, the final beneficiary turns out to be the citizens, and this requires very strong focused effort of the local governments to communicate with citizens to reach some agreeable point on what the city is implementing this kind of technology and this kind of algorithm, make it transparent, and also disclose the potential risk and the measure that such authorities are taking, and finally to assess if the citizens reach agreement to introduce such into the community. And this is taking place in some of the municipalities in Japan that NECs were partnering with. And this is some example that I could now bring up at the moment.
Thank you, Yasunori-san. I have one question to Rakesh. Rakesh, having worked in the disaster management humanitarian sector for decades, you would know about the post-disaster / post-crisis needs assessment, which we undertake after every disaster. And every UN agency undertake them, and every other agencies undertake them. And after every disaster, there's a flurry of disaster needs assessment. The question is, are you familiar with any AI application which can help with the needs assessment? Or is there any plan to develop something like this? And I may also add that, is there a way in which we could prompt such a development if none exists? Thank you.
Yeah, no, thank you so much. I think that's a really good question. So there are algorithms that exist. So for example, Pager is one where when there's an earthquake or some other event from OCHA, within a few minutes, I get an email with a notification and a predictive model of how many people were affected, what kind of infrastructure might have been affected, things to this effect. And this is actually a very good decision-making tool in the early phase of an event to say, is this something I need to care about, or is this something that probably is not worth so much in interest there? Now, you specifically were talking about sort of the recovery side, which is, you know, if you think about the initial event going into a response where there's a lot of rescue and emergency work, and then into early recovery, and then into longer term development work, I think that there's more opportunity for collaboration there. I think there's more opportunity for work there. There is, at the highest level, there's an initiative called the Grand Bargain, and the Triple Nexus. These were things that came out of the World Humanitarian Summit back in 2016 to bring together these worlds of humanitarian work, which have traditionally been around crisis and emergency response, and development work, which is more around like longer term development and the SDGs more generally. And I think that that is a very interesting intersection that I would like to see more work in the coming years. I would be remiss if I didn't take this opportunity to say that one thing that should be emphasized is that when we talk about stakeholders, ultimately the most important key stakeholder are the individuals and communities being affected by AI, and that they must have a robust seat at the table. If it's just us on this call having this conversation, then we are missing a key constituency. And so I just wanted to call that out and name it. Thank you.
Thank you, Rakesh, for those remarks. We now have about 4 minutes left, so I would start to conclude the session. We still have more than 200 people on the call, which is exceptionally good considering that in many parts of Asia, it's already close to midnight. And many people are still there listening to us. So before I conclude, I wanted to ask if Bilal want to say a few words about what he found today, and couple of things about what the study group could pick up from today. Bilal?
Thank you very much, Murali. This has been a great dialogue. I think the questions and answers are still going. So I think we have a great opportunity to continue the dialogue in the focus group. And I, of course, invite Monique as the chair of the focus group to maybe say a few words on how she plans to handle this. And I really want to take this opportunity to thank all the speakers with the excellent insights and knowledge that you shared with us today. And the audience that I've seen has been more than 300 and some connected live, joining us from around the world. Thank you very much for your interest. And we look forward to continued engagement through the focus group and other means. Thank you.
Thank you, Bilal, for those words. May I ask Monique to give you words about what insight she has picked up and how she plans to take it forward in the focus group.
Absolutely. Thank you so much, everyone, for your active participation, thoughtful questions and comments, and interest in the topic. I encourage anyone with open questions or with closed questions to join the focus group. Like I said, mark your calendars, 15th to 17th of March. Registration for the workshop and meeting can be made on our website, and we also encourage you to join our mailing list. I look forward for the discussion to continue. Thanks.
Thank you, Monique. I now invite the speakers if they want to make any last 30-second pitch on the topics. Anthony, if you want to say a few words about.
No, I'd just like to say thanks very much for the opportunity to speak, and thanks very much to the other panelists. Thanks for everyone who's been tuning in. I think this is a really rich area where we can see some future collaboration, and I'm really happy to provide support from my area within WMO for this. Thank you.
Thank you, Anthony. Yasunori-san, if you are connecting from Japan, thank you for staying so late. But please, any final words?
Yeah, the coming up with ethical and responsible AI is a very important but difficult task, and I don't believe there is any straightforward theory that people will develop. So I really appreciate the organization like the United Nations and this kind of a standardization organization as an opportunity to share good practices, best practices by making collaboration in the international space. And so I really thank you for all of your thoughts and interventions, and also the discussions. Thank you very much.
Thank you, Yasunori. May I now ask Rakesh if you want to add any final words and anything which you would like to get us from the UN system to support your work in the Silicon Valley?
Thanks so much. First of all, thank you for your moderation today. And thanks to all my co-panelists for all their really interesting remarks. I just want to circle back and just say that, we know intrinsically that technology is not inherently good or bad. It's what we do as human beings with it that really matters. And this is why the ethical and humane use conversation is so critically important, because the technology does not just magically infuse itself with a moral quality on its own. It's all up to all of us to do that. And I just welcome follow-up conversations with all of you and all interested parties to keep this conversation moving forward. So thank you so much.
Thank you, Rakesh. I will now invite Cameron to make any final remarks. Same question, whatever you would like to have from the UN system.
First off, just thanks to everybody. Thanks for the great questions that came into the chat. I really appreciate it. And thanks to all the panelists out there. This was a fantastic session. Yeah, highlighting actually what my colleague Rakesh was saying, like we look forward to investing in the space. We look forward to doing even more with the idea of enhancing human capacity and not replacing it. Nothing that's being done here should be used in that context. These are not perfect solutions, and nor should they be thought of, but they're powerful ways to help folks both prepare and respond to disasters. And for the UN system and for the others and the folks out there, love to support data consolidation and sharing. We like to see larger public data sets to be utilized and for others to build off of, and look forward to working in that space. Thank you, everybody.
Thank you, Cameron. And I want to thank all the speakers and Bilal. And I also want to thank ITU for giving me this opportunity to chair this great session. I want to thank all the participants, more than 170 of them still online till the very last minute. There will be more sessions on AI for good and AI for disaster management. So please keep in touch with us. The technology is moving forward very fast, and we are hopefully moving towards a safer world. Thank you all.